So hello, I am Decadet Yaban and I am the reporter for the Group 7 and the members are Decadet Mancao and Decadet Merto. So I'm here to discuss about the compass variation and deviation. So first, let me explain on how variation works. We have to keep in mind that there are two norths, which is the true north and the magnetic north. True north is situated at the peak of the Earth while the magnetic north's location is not constant. All steering compasses, hand compasses, and other magnetic devices all points towards the magnetic north. On the other hand, charts are all oriented towards the true north. So the angle between the true north and the magnetic north is called the variation. The angle between them changes onto where you are situated on the planet. So around around the coast of UK, variation is around to 4 degrees west to 7 degrees west. In the other parts of the world, it can reach for more than 50 degrees east or west. Because the magnetic North Pole moves, the variation changes from year to year. The compass rose on the charts gives the annual change for around 7 degrees east per year around the UK. Consequently, we need to know how to calculate the difference between the magnetic north and the true north. We can only plot true headings on navigational charts as these are oriented to fixed point of true north. Using the chart, true north is the main course for direction because it doesn't move unlike the magnetic north. Now that we understand the difference between the true north and the magnetic north, let us discuss on how to plot our true headings using the variation. On charts, we need to look for the compass rose in order to identify the variation for the specific place. And as it was discussed earlier, that the magnetic north differs on where you are situated in the planet, so the use of the compass rose is vital in solving the variation. The simple way to remember it is that whenever the variation is west, the magnetic bearing will be greater than true, as you see on the diagram on the side. You must add variation to the true bearing to get the magnetic north or subtract variation from the magnetic to get the true north. So we need to understand and keep this in mind that when the variation is west, the magnetic is best. So the magnetic compass is greater than the variation, or greater than the true north. However, when the variation is east, the magnetic compass is least. So the true north is greater than the magnetic north. So next, let me give you an example on how to solve the variation. When you're given the true bearing of 273 degrees true and a variation of 5 degrees west. So when the variation is west, we will add the true bearing and the variation. So the magnetic bearing will be 278. So variation is west, so meaning the magnetic bearing is greater, so magnetic best. As you can see, 273 true and versus the magnetic bearing 278. So this means the magnetic is best. So next example is the true bearing. The given is 0 degrees 8 degrees true and the variation is 13 degrees east. So the variation is east. So as we can see, variation is magnetic least. So we subtracted 13 degrees to 8 degrees true. So the magnetic bearing is 355 degrees. So next example is magnetic bearing 273 degrees and the variation is west. So west meaning the magnetic bearing is greater than the true bearing. So 273 magnetic bearing minus the 7 degrees variation. So the true bearing will be 266 true. So next, we'll discuss about the compass deviation. We all know that the compass is a magnetic device and it is interfered by the magnetic north. It also goes the same by being interfered with the vessel itself, because we all know that the vessel is made by metals and has equipments like steel engines, keel, ferromagnetism, electromagnetism, like loudspeakers, mobile phones, handheld VHFs, and other deck cargoes on ships. This is called the deviation, and it will vary with the heading of the boat. You can plot a graph on the effect of the change in boat heading on the deviation. This is called the deviation curve. Deviation can be measured by swinging the compass. That is, checking the compass reading when the boat is on a known heading. Round a 360 degrees series of heading, plotting the resultant errors. You can then read off the deviation and apply this on the boat's compass heading to get a magnetic course, or vice versa. Apply it to the magnetic heading to obtain a compass course. So there is a deviation present in using a magnetic compass, because the vessel itself is made up of metals. And as you can remember during our physics on grade 8 or grade 11 or 12, there is when you rub your feet on a certain rug and then you point your finger on a doorknob, you will feel a magnetism. So it is the same inside a boat. A vessel is made up of metal, and it has engines, it has speakers, it has VHF. All of those equipments produce friction. That is why the deviation is present on a vessel and will always affect the use of the magnetic compass. So now let's discuss about the compass deviation card, or the swinging the compass. So first, locate two transit objects and determine true bearing on the chart. Second, secure the boat at anchor so that the transits are exactly aligned. Swing the boat's head until it is pointing due north. Third, read off the transit bearing on the compass and apply the variation. Fourth is, the difference between this result and the true transit bearing is the deviation on this heading. If the true bearing is greater, the deviation is named east. If it is lesser, then the deviation is named west. Fifth is, repeat the procedure taking transit bearing on each of the cardinal points. So 6, from the result, make up a deviation card. Further errors are caused by boat heel and difficulty of reading when on a moving platform. An electronic compass can be set up to remove the effect of deviation, but it is still a magnetic compass. So hand-bearing compasses usually show very small deviation effects, which can be ignored if you use them away from the magnetic area. So deviation can also be east or west, but the same logic applies. Deviation west, compass best. So when the deviation is west, the compass is greater than the true bearing. So when the deviation is east, the compass is less than the true bearing. So we'll give you an example. So let us review first. So when the variation is west, we will add the variation to the true bearing. So when the variation is east, we will subtract. Next is, when the deviation is west, we add, and then when the deviation is east, we subtract. So when the in the variation, when the direction is west, we always add it, even though if it is variation or deviation. So while moving towards right to left, the CDMVT, we subtract west when the variation is west, and then add east when the variation is east, and then subtract west when the deviation is west, and add east when the deviation is east. So right to left movement, the CDMVT, we always add east and subtract west, no matter if it's variation or deviation. We just look at the symbols. So number 1, the true bearing is 114 and the variation is 4 degrees west. So we will add it. 114 plus 4 is, so the magnetic bearing will be 118. And the deviation is 5 degrees east, so the direction is east, so we will subtract. 118 minus 5 is 113. So number 2, we will use the from left to right. So first is, we can see that the variation is 7 degrees west and the magnetic is 309. So we all know that the direction is west, so we will add. So 7 plus 302 is 309. So the true bearing here, it will be 302. And then we can see that the compass bearing is 314. So we will find a number that will add 309 to become 314. So what number will that be? So it will be 5 west. So we must have the direction west in order to add 309, in order to come up with 314. So number 3 is 50, the true bearing, and then the variation is 6 east. So as we can see, east. So we will subtract. So 50 minus 6 is 44. The magnetic is 44. And then we can see that the compass is 44. No addition or subtraction, so the deviation will be 0. So the next number is, we can see the given 2 degrees east to 48, the magnetic, and the deviation is 2 degrees west. So as we can see, 248, and then the variation is 2 degrees east. This means that we subtracted. So the true bearing will be 250. And then as we can see here that the deviation is west. So we will add the 2 back, and then the compass bearing will be 250. Number 5, 156 is the given, which is the true bearing. And then the magnetic here is 148. So this means that we subtracted. So the direction here will be east. So 156 minus 148 minus 156, it will be 8 degrees east in the variation. And then the deviation here is 5 degrees east. So we will subtract again. 148 minus 5 is 143. Number 6, 358 for the true bearing, 9 degrees west for the variation, and the magnetic is not given. So 358 plus 9. So as we all know that when the given adds to 360 and above, we will go back to 0 and then start up again from 1 to 360. So 358 plus 9 degrees west, so it will be 7. The magnetic will be 7. And then the deviation is, as we can see, 7 plus, and we will, as you can see here in the compass, the answer is 10. So this means that we will add 7. What number will add up to 10? So 3. And then the direction will be west, so that we can add. So the answer is 10. Next is number 7. Number 7 is 004. And then the magnetic is 58. This means that it's subtracted. So the direction is east, and then the number will be 6. So this means 4 minus 6, it will be negative 2. However, when the number lowers than 0, it will go back to 360. And then the 2, that's why the answer is 358. And then the deviation here is 4 degrees west. So we will add again. So the answer here in the compass is 2. Next, for number 8, as we can see, the compass, the true bearing is not given in the magnetic. So we will use CDMVT. So from right to left. So 191 and then 3 degrees east. So as we all know, when using the CDMVT, we always add east and always subtract west. So 191 plus 3 degrees east, it will be 194. So the magnetic bearing will be 194, I mean. So next is the deviation is 6 degrees west. As we can see, the direction is west, so we will subtract. So 194 minus 6 will be 188. So the true bearing will be 188. So that's all for the examples. I hope that you understood the lesson that I have discussed, and that's all for group 7 for the compass variation and bearing. Thank you.